What's up, guys? Mr. Moore here. Let's do a little review for this waves test that we have coming up tomorrow. So let's just jump right into it. What do I want? That's good. So an unstretched spring has a length of 10 centimeters. When the spring is stretched by a force of 16 newtons, its length is now 18 centimeters. Find the spring constant. So what they're telling you is that a certain spring has a length of 10 meters or 10 centimeters. All right, when it's not stretched. But then you stretch it, and now it's 18 centimeters. And they're using 16 newtons to do it. So, Hooke's law, F equals negative kx. Remember, the negative just means that the force is in the opposite direction of the stretching, right? Because if you stretch it to the right, it means the force wants to act to the left. So, F is the force. They gave us that, 16 newtons. We don't know what the spring constant is. We're looking for that. And X is how far it got stretched. Well, if the force is 16 newtons and that wants to act towards the left, then it got stretched a displacement of 8. All right, it was 10, went to 18. So we'd say that got stretched up negative 8 or 8 to the right. So this gives us 16 equals 8k divided by 8. K equals 2 Newton, and we're in centimeters here. Okay. Question 2. The graph below shows a relationship between the force applied to a spring and the compression. So spring compression, this is Hooke's law again. Find the spring constant. So we can pick any single point along this line because these are all points that apply. So let's pick this point right here. All right. At 1, it was displaced 0.4. So again, Hooke's law. The force is 1 Newton. 1 equals negative kx, and an x in this case is negative 0.4. So we have 1 equals 0.4 times k divided by 0.4. And then we get that k equals 2.5. Now we're in Newton meters this time. All right, the time required for a wave to complete one full cycle is called the wave's period. This is just by definition. The period is how long it takes to do one full cycle. If I'm talking about pendulum, it's the time it would take to go to one side and come back. If I'm talking about a wave, it's the time to do one full wave, so an up and a down. Remember, frequency is how many are occurring in a given amount of time. Velocity is how fast they're going. That's the formula V equals F times wavelength. And then wavelength is how long the wave actually is. Like if you got a ruler and you measured from this point to this point, how long it is. Let's look for what is the period of a wave whose frequency is 256 cycles per second. Well, you guys have the formula T equals 1 over F, or you can also write it as F equals 1 over T, depending on what you're looking for. In this case, you're looking for period, you're searching for T. They're giving you a frequency, it's 256. T equals 1 over 256, and it's as simple as that. Alright, question 5 here. Diagram below represents a transverse wave. The wavelength of the wave is equal to the distance between which 2 points? So, remember, wavelength is the distance between two similar points. Let's look at A and G. So, A is here, G is here. No, that's way more than one single wavelength. B and F. B is here, F is there. That is one wavelength because they're both at the crest, right? C and E, well, those are too close. And then D and F. D and F would be a trough to a crest, but that's definitely not one wavelength. Wavelengths would be like B to F would be one. A to E would be a wavelength, or C to G would be a wavelength. Okay, which diagram below has wavelength and amplitude correctly labeled? Remember, Amplitude is how high it goes from displacement. Wavelength is how far from a point to a similar point. So this has the right amplitude, but that wavelength is too short. This one has the wrong amplitude. Can't be that. This one has the right amplitude, and this looks like the right wavelength. And let's look at this one. That amplitude's wrong, so 3. The energy of a sound wave is most closely related to energy you need to associate with amplitude. The more amplitude you have, the more energy. Okay? Amplitude doesn't affect the frequency of the wavelength. It's just how loud something is, if we're talking about sound.